So we just did slides.
Yep. So where we left off last time was hashing. So we talked about hashing and now we're done. And the rest of this is more concrete examples of security difficulties. So the first one we'll talk about, spam accounts. All right, spam accounts are those phony accounts that people set up for whatever reason to try to make phony friends on Facebook or try to do activity. So, created for a fake persona, typically to deceive or harm other users. For example, you might use it as an advertising tool, right? You might have something that you want to sell, so create a phony account to try to do phony word of mouth, whatever, right? You say, oh, hey, you should try out this new refrigerator because it's great. You set up a phony account to do that. Of course, contacts for criminal activity, right? So there are a fair number of these accounts out there, right? So what you get on Facebook, of course, I'll go to my own account here if I can access it. Facebook network's always been a little bit of a problem. Well, we'll get it eventually. But you know what it is, right? It'll be like, if you're a male person, you'll probably get some ridiculously underage girl in a bikini be like, hey, you want to be my friend? And I'm like, I think I'm a little too old for you, sweetie. Or, you know, if you're a woman, right, you'll get some handsome dude in uniform that, you know, is conveniently deployed overseas and is going to ask you for, you know, money and smokes and whatever. So those are the sort of things you get. Influencing public opinion, right? People make swarms of bots. So, for example, if there's, you know, politics was a thing, if there's some page about some candidate, you could get a flood of bots on there to all do like thumbs down or thumbs up. Recently, not even this, there was a similar thing. So you guys are aware of the Armenian Genocide, right? And I know that Turkey has a whole thing right now. They don't want it to be called a genocide, but anyway, some really bad stuff happened about 100 years ago over there, and they made a movie about it here in the States lately. Well, there were a bunch of, I presume, mostly Turkish people that were kind of outraged that they made a movie about it, and so they all flooded onto Rotten Tomatoes to give it like, you know, thumbs down ratings ahead of when anybody could even see it. Yeah.
More recently,
yeah.
What happened with Venom?
Oh yeah.
All the Stars Born.
Yeah, yeah.
They flooded it down.
And the Captain Marvel, too, right? Because that was, yeah. So, you know, this sort of stuff happens. I think in most of those cases, those are probably real users, but the result would be the same if they made just a flood of bots to do it as well. Yeah. And, of course, gathering information about other users. You can try to learn more about them so that you can maybe have a good guess at hacking their account. For example, some famous person, you try to find out the name of his dog or his wife's birthday so that you can guess his PIN codes, things like that. Anyway. Symptoms of a spam account, how does Facebook recognize them? Well, number one, practically no personal information, right? No posts, no photos, whatever. Negligible interaction with friends, right? So if you're a normal person on Facebook, yeah, maybe you're not on there every day, but when you are, you know, you send people messages, you post things, you like other people's posts, stuff like that. If it's a really spammy account, there's only going to be one activity type. For example, if you're there to scam people out of money, pretty much all you're going to do is send out instant messages. If you're there to influence public opinion, you're going to go onto various pages, and what you're going to do is do thumbs up or thumbs down on stuff like that. The other thing, typically get bursts of friend requests, right? So right off the bat, this kind of spam account gets set up, and boom, they send out, you know, like 2,000 friend requests hoping to get a bunch of friends, right? Normal people don't do that. Normal people, they join Facebook and there's kind of, oh, right away they might meet a few people, next day meet a few more, next day meet a few more. They have a really big burst of friend requests right off the bat. Yeah, it's going to be a trigger. Okay, so how does Facebook detect them? How do these accounts avoid detection? Well, it's a lot like the same thing that happens in your spam box, in your email box. So Facebook builds a profile of what normal behavior should look like. If there's a very strong deviation from that standard profile, then they're going to say, hey, you know, this account looks suspicious. Also, it could be flagged by users. For example, right, so I think I'm into my own Facebook now, and we can do this. I'll show you who's in my friend box lately. I got some fun ones, right, some implausible friends. Oh, thank you. Yeah, it exists. I don't know, we'll get in there eventually, maybe. Yep. Yeah, I wasn't going to use my UIC email. I don't know why it's slow. We'll get to it. Okay, maybe it'll be done by the time I'm done with this slide. So, inevitably, there are going to be some false positives and some false negatives, right? We all know this happens with email spam, that sometimes a valid email ends up in your spam folder, right? And sometimes, maybe it doesn't happen often for you. It happens for me a fair amount because, you know, obviously I get email from a lot of different sources, students using unusual emails. Sometimes it gets sent as spam to my account. And of course, not all spam makes it into the folder, right? Sometimes things that should be spam, they end up in your regular box. So, it's not a perfect system. Anyway, the way these accounts survive, number one, operating at small scale. So if you joined Facebook with the idea of setting up a phony account, and on your first day you sent out 2,500 friend requests to try to fill up your potential friend roster, Facebook would say, there's something up with that. That seems a little fishy, right? But if you join and on the first day you send out 5 friend requests, there's nothing particularly suspicious about that, right? Facebook will say, yeah, okay, 5. Maybe that's a little more than usual, but it's not enough to really throw any red flags. Of course, recycling accounts, right? Once you create an account, all you need to do to create another account is a new email address. You auto-generate a new email address, and then, you know, add a new profile picture, and boom, try to create a new account. So if Facebook shuts down one, you just make a new one, go through the same process. The really smart ones, they'll try to mimic actual user behavior. So they'll do things like engage in a mix of activities to the extent that they can write scripts that do that. They might install games. I know people have actually written scripts to play Facebook games. There was a friend of mine about 10 years ago. Her husband got into a thing. You guys ever seen Bejeweled Blitz on Facebook? Yeah. He got into a thing with one of his friends where they were super competitive against each other until finally they said, you know, I'm just going to write a script that plays Bejeweled and then I'll, like, you know, blow you out of the water because it'll happen at computer speed. So yeah, you could potentially do that. You could set up an account and have it every, you know, couple hours go in and play a few games of Bejeweled, and Facebook would think, oh, this probably isn't a bot. You know, it's sending out a limited number of friend requests. It's randomly, you know, looking at pages that it's interested in, and it plays some Bejeweled. You could probably fool a security tool if it's not too, you know, sophisticated. So, to the extent that they can devise these bots to actually act more or less like humans, they become much harder to detect. And the arms race never ends, right? So, always, Facebook is trying to, you know, pin down the actual standard profile, and once the bad guys see what works and what doesn't work, they're going to stop doing what doesn't work, and going to follow up with what does. All right, so let me see if I got this finally. There we go. I have a whole lot of shit on here. All right. Let's see what's going on in my friend world. Oh, I see. I have a shit network connection. That's what it is. That's how, you know, when your page looks screwy like that, that's because, yeah, it took a while to load things and it kind of gave up doing it sophisticated. Okay, so here's who's this? Oh, she's a cutie. Who are you? Layla Freya Razaev. Oh, she lives in Evanston. How nice. Ooh, and look at her. Oh, look at that rack. Okay. And she has 2 friends, right? So just, you know, it's like, okay, you're a very nice looking girl. I don't think I'm really what you're looking for. So, anyway, and no friends in common because she only has 2 friends. That's great. Okay, so that's not really a plausible friend request. Okay, very nice. So, some business guy said this, I forget who it was, I lifted the quote several years ago, and he said, there's 2 kinds of businesses, ones that have been hacked and ones that don't know it. So every business out there has, to some degree, been compromised. There are people probably looking at things they shouldn't have been looking at. Now, we've already established perfect security is impossible, so what managers have to think about is how to balance usability against security, right? Basically, if you don't have good security, there's the cost of damage, right? But if you have too much security, it imposes a cost on how much of a hassle it is to use the system, and eventually people might abandon the system. So, let's discuss this. Suppose you work at a business, and the manager is very security conscious, and he says to you, okay, our system is password protected, and I demand that everybody changes their password every week. And you're a good employee, so you don't tell them to go fuck off. You actually, you do it. You say, okay, we'll change our password every week. But how do employees do that? How might that play out? Yeah, that's one thing, right? So let me write this up. So demand for weekly password changes, right? Number one, employees might write password on paper by desk, right? That's a problem. What else? What else? Yes.
You might only shift it by like one letter.
Yeah, right? You might make minor changes like a single new character. Sure. What else? Yeah.
They might forget the password since they're changing it so often.
Oh, yeah, they might forget the password and need to call help desk, right? Things like that. Okay, one more thing. One more thing. What if somebody says, you know, I'll change my password every week, but I don't want to remember a whole lot of passwords. What might that person do? Yeah.
If you want to know like the limit on how many, if you're not required to change the you can use 2 passwords and just keep looking.
Yeah, you can toggle back and forth between 2 passwords, right? So swap back and forth between 2 same passwords, right? You could do stuff like that. But of course, what the manager wants, he wants everyone to develop a completely new password every time. And so this one is going to be a consequence, right? I'm going to lift these down below. Okay, so manager wises up, demands entirely new passwords every week. Okay? And so that could happen. Employees write it on paper, or again, yeah, people are going to forget the password, right? And they're going to have to call the help desk. So, what might happen following on that? So the manager says, right, we'll say, sure, I have to do passwords every week, so or store them in a document, or store in document, whatever. If the manager demands no paper storage or digital storage, and people actually follow that, yeah, a lot of people are going to forget their password. They're going to have to call the help desk all the time, which is basically going to have consequence, reduced system, efficiency, time loss, right? So instead of actually getting on the system and doing your stuff, you get there at 8:30, you forget your password, you got to call down to the help desk. But guess what? There's a whole line of other people waiting at the help desk. You don't get into the system until 9:30. Big headache, right? A lot of wasted time. So, last follow-up for this, okay? What else might happen? The good people at the help desk, they're humans, and perhaps they're not as obedient as all the other workers. Maybe the help desk is overwhelmed. And what might they do? They might offer a skeleton key password, right? Universal, like admin, something stupid like this. Oh, you can't get into the system? Yeah, just use admin, right? They might create their own backdoor into the system because those people have the capability to do it, right? They're the actual security people. They might be able to create some kind of dummy account that anybody can get into. Or employees might stop relying on the system. They don't want to use it. The security is too much of a hassle. They're just going to try to bypass it however they can, right? Running stuff on paper or downloading their new files once a week right after they create their password and then try to work with just that. So there are ways that people deal with it. But the point is, arbitrarily demanding a very high level of security is likely to result in some kind of way that employees evade the intent of the security. Okay? Employees will tend to obey the letter of the law, but often will bypass the spirit of the law because it can be too much of a hassle. Okay. Does that make sense? Yeah. Hope so. Okay. So, we'll now cover a whole bunch of notable security threats. So, hacking, phishing, multi-stage attacks, denial of service, cross-site scripting, SQL injection. And then we'll talk about some of the things that Facebook has actually experienced. So, first one, brute force attack. In computer science terms, a brute force anything just means you're trying every possibility that there is. So a brute force attack to hack a password means you try every legitimate combination of characters that could be in a password. And the thing about a brute force attack is it will eventually work, right? If you say, I am going to try everything, well, one of those combinations has to be the right one. If you try them all, you will eventually find it. Problem is, eventually it could be a really, 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 really long time, right? And by the time you actually do manage to hack it, whatever, it's the year 10,042 and we're all gone. So, practical solutions to brute force attacks. Number one, strong passwords, right? A lot of characters, a lot of variety of character possibilities. You do that, a brute force attack is going to take a really, really, really long time to work. The other thing, of course, enforced delays or locking account after a number of failed attempts, right? So you make 3 failed attempts, you get locked out of your account for a while. That's going to slow things down. Maybe you actually have to talk to a human to try to do it. Now, in a well-designed system, brute force attack is not a severe threat, right? You have enough possibilities that basically hackers aren't going to try this kind of brute force attack. But again, not all systems are well designed, and we'll come back to that. Second, guessing and stealing, right? So, guessing a password might seem pretty much impossible, but it does happen, especially if passwords include personal data, right? Names or birthdays of spouse or children, or dogs, whatever. So if your dog's name is Fido, and he's born in, I don't know, August, you have your password Fido August or August Fido, something dumb like that. Yeah, people might be able to guess it. And of course, dictionary attacks, passwords that include common words. So quite often when you try to create a password for a well-designed site, they'll say, your password cannot contain any complete words, right? Because to reduce the possibility of a dictionary attack. And passwords can be stolen. Number one, intercepting wireless data, right? Any wireless data that's sent out over a wireless network, somebody can listen in and see what you're sending. They might be not able to interpret it, right, especially if it's encrypted, but they can capture data that's sent. Other stuff, keystroke logging on public machines. There are little physical tools you can use to do that, to try to track what all things people type into the machine, and then you have that kind of keystroke logger afterwards. Malware access to locally stored passwords. For example, if in your browser you give your browser access to whatever sites you use and you say, okay, save this password, well, that's there in your browser. And if there's some malware out there that gets access to that stack of passwords, guess what? They can use that, transfer, pretend they're you. Identical passwords from insecure sites, right? You use the same password on multiple sites. Maybe they don't all have good security. Maybe one of the sites is really dumb and stores passwords, in plain text instead of in some encrypted form. And of course, phishing. Phishing. Okay. So, phishing is basically an example of how when the banks make a stronger vault door, people come in through the roof. Okay? So, back in the day, passwords were not especially strong. Has anybody ever seen the kind of crappy 80s movie War Games with Matthew Broderick? Is that right? Yeah? No? You have. What happens in that game? What happens in that? I'll give you the gist of it. So there are some bored teenagers, and they try to hack the Pentagon into this AI system to simulate, a nuclear war simulator. Do you remember how they get into the system? As I recall, and it's been a while since I've seen it, there's a 4-digit PIN to get into this highly secure Pentagon system, and they just do a brute force attack on it. Dude writes a little script, goes blur, runs through all 10,000 possibilities, and they get in, like in a couple seconds. Okay? That's a lot of stuff was like that. A lot of stuff was not very sophisticated because network systems like that, they weren't open to the broader public. They were basically, for insiders who were relatively trusted. But if somebody got through that outer shell and figured out where these things were, yeah, security just was not all that good. But over time, more strictures on passwords get longer, these lockout times enforced if somebody, guesses wrong a few times. Passwords got stronger. And so the bad guys stopped trying to guess passwords. Instead, very popular thing, they try to trick you into giving your password. And that's what phishing is. users get duped into giving up their ID and password to a phony site. So, typical attack method, send some email advising the reader that there's some problem requires you to immediately log into their secure site. And they put a little link in the email so you know where to go. Reader visits the site, enters ID and password, and then they got it, right? Or you can send an email with some kind of malware attachment, some kind of executable file or a PDF document that's infected, something like that, and they can lift your account information. Now, this is one thing that you might have had conversations with your grandparents about. I remember it was about 10 years ago, and my mom, who was like 80, she would call me like in a panic, and she says, Doug. And I said, what? And she said, I got an email from Bank of America today. And I said, okay, doesn't sound so bad. And she said, it said that, you know, my account may have been compromised and I need to log in and, you know, update my password. And I was like, okay, so go to Bank America and do the change password stuff. And she's like, but Doug, I don't even have a Bank of America account. And I said, Mom, this is what's called phishing. This is phishing. Okay, so yeah, you know, you will eventually get those panic calls from your grandparents, I suppose, if you haven't already. Okay. Now for phishing, it's vital to preserve the illusion of legitimacy, right? One reason, there's typically a long delay before the damage happens, right? Just like if they get a stack of passwords from a site, they're probably not immediately going to target them the same day. They're going to try to shop those around. They're going to try to sell them to other people, and it might take weeks or even months. So there's typically a long delay before you give up between when you give up your password and when any damage actually happens. And passwords could be changed in the meantime. But what you don't want is somebody to go in and change their password and then like 10 minutes later think, oh shit, that was probably just a phishing attack. I better go, you know, I know I gave them my stuff, but I better go and change it to something different anyway, just in case, right? You don't want people to have that kind of second thought about it. So, what phishers often do, use some kind of phony but plausible email source address, right? So, instead of having, instead of bored teens at Dad's Garage, .com, or, I don't know, Bulgarian hacker at hack.net, right? You don't want that to be the source address. You'll do something like, you'll do spoofing. You'll pretend you are, customer help at targethelp.com, right? You'll do something, oh, that sounds plausible, right? Sure, they want to help me. That's wonderful, okay? You want to do something like that. Okay. Other stuff. Phony site with similar URL, right? So one of the things they might do is use a subtle change in password, subtle change in the site name. For example, instead of bankofamerica.com, right? They might do something like, if you're not paying close attention, bankofamerica.com. They'll do things like that. They'll swap out an L for an I or a 0 for 0 or like one of the many slightly different letters. They might use a lowercase Greek omicron instead of a regular O. Looks a little different. All sorts of little trivial things like that they could potentially do. So, and if you're in a rush, right, if you're not paying that much attention, you'd be like, yeah, okay, whatever. I'm not really looking at the link. I'm just going to go there. Okay? Reordering and merging terms, right? So target.com is a site, but targethelp.com will be a completely different site, not actually affiliated with the target organization. If you wanted to do that, it should be something like help.target.com would be the correct format, but not everybody knows that, right? Especially a lot of the old people that fall for phishing attacks. Last really devious, tricky thing they do, after somebody enters the password on this phony site, then you tell them, oh, no, that's not your real password. And then link them to the equivalent legitimate site, right? So if you go to, bankofamerica.com, right, then enter password and ID, they have it at that point, and then site redirects you to the legit Bank of America site, you enter in actual ID and password, and you get in, and you think all is well. Okay? That's the sort of stuff that could happen, right? So you go to the phony site, you enter in your stuff, you give away the keys, and then they say, oh, no, sorry, that didn't work. Please, try again. But then they load up the actual Bank of America page, and you enter in your stuff, and everything's fine. You think, okay, that's good. All right. So that's something that, a lot of the different tricks that phishers use. Okay. Related to that, we'll talk about spoofing. So spoofing is misrepresenting a name. And it's not always done maliciously, right? Sometimes, basically what it is you can have the text associated with a link be different from where it goes to, right? And it's not necessarily malicious because you could have a link that says, something like, click here for more info, right? It's not the name of the website, but it's just the text, right? Text actually shown. And we might say links to, uic.edu, because that's the more information you're looking at, okay? But with that kind of thing, they can actually have this text, say anything, right? It could be like to appear to be a different website. Okay. So, different internet address, different website name, different email address, all sorts of things like that. Now, phishing, of course, naturally is going to use that kind of disguising because it wants people to open the message, wants people to trust the message, not think there's anything wrong with it. So it's going to cover up those links to, bad guys at badguys.net. It's going to cover that, with something that looks plausible. Now, if you've looked at some of these phishing things, you'll know a lot of the attempts are just kind of sad, right? They're amateurish, there's improbable names, there's sloppy text. Let's see if I can find something good in my spam folder. Yeah, that was a popular thing. They busted a bunch of those guys a few weeks ago. I mean, I know they periodically bust them, but they busted like a big ring of those guys. Let's see what's in my spam folder. There's usually some good stuff. Ooh, 65. Yeah, pitch your ideas. Well, it looks shifty. I don't have that much. Oh, this is good. Hi, do you remember me? I am Rona, colleague. I don't remember a Rona. Let's see what you have to say. Ooh, suspicious link. Hi, I am Rona, your ex-coworker. Remember me? Some cool, interesting part-time job for you. Yeah, oh, look, that site looks reputable. That doesn't look like it was auto-generated by a bot. Yeah, seems suspicious. Okay? Yeah. Okay. So you get the idea. I mean, this is just kind of sad, right? You would look at this and be like, oh, I don't know you. I don't know you, Miss Rona. I'm sure you're very nice, but I do not know you. Okay. Anyway, one of the new things, I shouldn't say new, I remember when it was new, hovering a cursor over a link in an email should cause a little pop-up of the actual link or destination, right? So if you go to your account and there's a link to something and the link says, trust me, I'm a perfectly safe link, and then you hover the cursor over and it says, bad stuff will happen. This will like destroy your computer, something like that. So yeah, that's one of the things in there. You can usually hover the cursor over those links to show the real thing. Okay. Now, phishing generally casts a wide net in that it's a numbers game. They try to target 10 million potential people in the hope that they'll grab a few thousand actual victims, right? That's the way phishing works. They don't really care who they get. They just want to, they get a bunch of people. So it's like throwing a big net into the sea where there's a bunch of fish. You don't really care which fish you get. You just want to get some fish, okay? And they need a large volume of attacks to get that small number of successes. However, spear phishing, you're targeting a particular fish, right? You're stabbing one fish with a spear. Important targets can be targeted as small groups or even individually, right? So if you want to look at the DNC hack, they used some spear phishing emails. They were targeting specific people. Another one, Sony. You guys remember the Sony hack? There was that movie about assassinating the North Korean dictator, right? And they said North Korea did not like that. And so they sent people to, hack Sony, and then they released all those embarrassing emails from the people up at the top. That kind of ring a bell? You remember? Yeah. Okay. That's what they did. Short version of that, hackers targeted employees with fake Apple ID mails. So, first of all, they did phishing attacks against some of the actual security employees, right? They did that. Once they got a few of those, they got the malware in, they started sending out emails to people at higher up, and they made it look like they were from the security operations within Sony. Because if you get some random email, from the outside, North Korean secret agent guy sends you an email, you'd be like, it's a little suspicious. But if it comes from Sony internal security group and gives a notification that you have to enter your password and change it through their secure server, whatever, but then that information gets echoed to those North Korean bad guys, yeah, you're probably still going to trust that. You're going to be like, internal security says I got to change my password. Fine, I'll do it, is what a lot of people would think. And that's basically what happened. They phished the security guys, and then they put in some malware to basically bulk send out emails to people up at the top of the hierarchy so they could access their email accounts and, pull all those emails. Okay. So that's the difference. Spear phishing, you have specific targets in mind. Ordinary phishing, you don't really care who you get. You just want to get some people. You send out like 10 million emails to get a few thousand. Spear phishing, you have an end target. Okay. Likewise, this is an example of a multi-stage attack, right? So this is a more sophisticated attack than just doing phishing, for example. Anybody can send out an email and say, hey, send me your stuff, right? Anybody can get a hold of some virus or other kind of bad malware that tries to install on your own machine. There's, it's available, it's out there. But multi-stage attacks are more sophisticated. So typically the way it works, somehow acquire credentials of IT security employees, right? Often with a phishing attack, although other methods are possible, okay? Then, once you get those accounts, use those security employee accounts to phish employees with elevated access levels. Things like the president, things like HR people, anybody that would have, top security people, anybody who would have wider access to the system. And then, once you've gotten all the data you want to get, round it all up and exfiltrate it. Exfiltrate is a fancy word for grab it and run for the door. So you're going to try to, basically download all of this data to some kind of anonymous file sharing service that once it gets downloaded to one of those, you have a mirror in place to echo it to the next one, and you echo it through like 6 different places, and at the end, nobody knows where the data really went or who you are. Okay, so that's the way that sort of attack usually worked, and that's, basically what happened at Sony. But multi-stage attacks, you target one group of employees, use those employees to target subsequent groups of employees. Okay. And that's a picture just demonstrating the process. Okay. Denial of service attacks. So, a denial of service attack is simply an attempt to overload the network. So, every connection request to a server takes a little bit of time to process. If you send out too many, basically the server's not going to be able to respond to legitimate requests. So you flood the server with, tens of thousands of connection requests, and the actual legitimate users, they're going to have to take a number and wait in line, and it's going to be kind of awful for them. So if it's from a single machine, it's pretty easy to block, right? People internally can say, oh, this IP address is sending us 10,000 connection requests. It's ridiculous. We're going to block that. And you can you can have an automated policy for that, that if, you get too many connection requests from one device, you simply block that device. Easy. But if you set up a whole group of machines to try to do this, then it becomes tougher, right? If you have 10,000 different machines, each launching one network connection request per second, that's going to take some more time to stop, right? They're going to have to say, oh, wow, this is a bit more of a problem. So, because you can't just say, oh, this one location is the problem. There's a large set, and you have to identify them as repeaters, and you may have a policy in place that says we can allow one request per second, so they just, they do that. Anyway, this kind of distributed denial of service attack means that the attack is distributed over a set of machines. There's a large set of machines involved. And typically it relies on what's called a botnet. So a botnet is a group of infected machines. So bot is an application, a machine, whatever, and a network of bots. So they're all working together for this goal, often controlled without the knowledge of their actual owner, right? You get some malware installed on a machine, and when the time comes that you want to do this kind of distributed denial of service attack, you just tell all the bots in the botnet, activate, do your thing, and here's your target, and you send them all in a swarm after it. So, the big solution to that, right? So one solution is having backup capacity. So if your system gets overloaded, you can kind of deal with that. But the big weakness is this. A distributed denial of service attack, one that's effective, is going to be too big to be controlled manually, right? A human is not going to be able to coordinate tens of thousands of machines, right? It's just too much work. So there has to be some automated process. So the defenders, they're going to look for usage patterns. They're going to recognize, like, there's a set of IP addresses all of these attacks are coming from. They're going to recognize the frequency of it. Eventually, yeah, they will come up with a list of things to block, and they're going to block them. And that'll be it. They'll say, you're probably part of this botnet attack. We are going to block you. It'll disrupt things for a while, but it can be recovered from. It's not, the end of the world. All right, we'll do a few more, and I guess we'll save some time for Friday. So, cross-site scripting. Core thing of cross-site scripting is basically a web page's input mechanism tries to put some scripting code somewhere. And there's different ways it can happen, but I'll show the simple one. Imagine if somebody put something on Facebook, right? They post this funny picture, haha, and there's comments down below, right? There's a bunch of little boxes for comments. And one person writes, nice. And another writes down something like, yeah, haha, funny. And another person writes a script that when it activates will mess up your day. Okay, that will be the script that they're running there. Somebody puts some active code into that block. Now, normally, this would be a script and it would be fine and nothing, really bad would happen if it's just as text. But if your web browser is not sophisticated, it could actually think that this ordinary plain text they wrote in here is actually a slug of active JavaScript code that when they load the page, instead of just showing it as plain text, they actually run that script. And that script could do bad stuff. Okay? Now, of course, Facebook is wise to this now. They're not going to let you get away with that. They're going to say, well, you can't, it's not going to let you actually run active code within one of these blocks. But that's the idea. Okay, so there's some active code where there shouldn't be, and the page is going to do stuff that you wouldn't think it should be able to do. All right. So that's one case. Other things it can do, again, the script's going to run when the web page gets viewed because there's some active code where basically there shouldn't be. It can put in keystroke loggers. It can capture session information, like basically the credentials you use to verify that you're logged into Facebook when you go from one page to the next. So they can grab that session key and use it on their own machine and then use it to, say, send out spam emails to all your friends. They can also create phony login objects as well. So they can send you to another page that says, oh, hey, here's the stuff you need to log in. Okay. SQL injection. SQL injection attack. We haven't really talked about SQL yet, but it's there in Access and we eventually will. The essential idea for this is in the password block, you put in some executable SQL code. So normally, what would happen is this. There'll be a block for ID, there'll be a block for password. For your ID, you write, I don't know, Doug, whatever. And for password, my password, whatever that is. Okay, and then the database checks, does this match, does that match? Runs it through some kind of hash function and an encryption function and says, okay, you get in, you get the account. But in a SQL injection account, you might enter something like, if somebody wants to hack my account, they say Doug, and then password, my password, or 1 equals 1. Okay? And the idea, what can work if once they figure out exactly how the database queries are structured, this will get translated into select everything. That's what that wildcard from, access from credentials, I guess. Sure. Where ID equals ID and password equals, my password. ID equals Doug. Okay, and password equals my password. So this is what, they would probably be checking on the inside. So select all the things, the star character there, that's a wildcard. So select everything from that credentials table where the ID field is Doug and the password field is my password. And if that matches, it gives me the access key so I can get in. Okay? But in this case, it comes out as select star from credentials where ID equals Doug and password equals my password or 1 equals 1. Okay, and you can see the problem here. This part, Doug is going to be true. I've put in the Doug, but this other part, and this or that, if either one of those is true, right, if either one of these things here is true, that part is going to resolve to true. So what it's going to do, whatever I've entered in as password, 1 is still equal to 1, that part is true. It will return the credentials from everybody whose ID is Doug, right? And there should only be 1 because, ID is probably the key field. That's a SQL injection attack. You try to run in some executable SQL code in the password block to fool the database into rewriting the query, basically. Yeah? All right, so I know you guys haven't seen SQL yet, really, but this is essentially the way it works. Now, this was a popular kind of neat thing 20 years ago, but again, systems are on to this, and they generally have blocks in place to prevent people from doing this sort of thing. Okay. All right, what do we get? 2 more slides? We'll do a couple more. I want to do a couple. Okay, so overview. Popular sites and software tend to draw the most bad guys, right? You go where the money is. So most scams are impersonal numbers games. You target 1 million people, you try to get a few victims. And I would also add as a postulate. A postulate is something that you can't prove it's true, but you think it probably is, and you're going to go with it. That's a postulate. So I would say, as a postulate, the scramble to keep up with demand, which Facebook has really been doing this past 15 years, tends to make security less rigorous, right? They're focusing more on content, on keeping users attached. Security, yes, security is important, but it's not like super secure, like a site that is all about like banking, financials or brokerages, whatever. Okay, over the last decade, Facebook has had a lot of problems, both against Facebook itself and against its users. So this is, again, the trade-off. Facebook wants to provide a safe, secure site, still wants to be fast and convenient, right? Doesn't want to force people to change their passwords every day, doesn't want to make them jump through a lot of hoops to access their stuff. That's the trade-off. Occasionally there are security problems. So I'll do this first. Well, all of these examples, they're not going to be asked about on the exam, okay? What it is, these are more concrete examples of what goes wrong. So one thing that Facebook still experiences a lot of, malicious login attempts. So up to 60,000 cyber attacks a day, and that was several years ago. So but they can't control people trying to log in maliciously. There's nothing Facebook can do about that, right? Somebody could just try. There's nothing you can do. Best thing is you can, number one, be more careful clicking on links on Facebook, which is kind of ridiculous given the number of links they get and the tricks that people go to make people do them. The other, you can also designate a group of trusted friends who can help you recover your account once it's locked. And that's good because it automates the process, right? Facebook doesn't have to man the help desk and verify your credentials, all that. Let me talk one thing about clicking on links, and then we'll call it a day. So, one of the tricks that, you know what, this comes up later. Never mind. We're going to call it a day right now. I'll see you all.